In this example, we need to solve the equation the square root of x plus 5 equals x minus 1. Well, what type of equation do we have here? It's a radical equation as it has a square root in it. And how many square roots does this equation have? Just one. So let's look at the steps for solving a radical equation involving one square root. Step 1 says to isolate the square root. Well, I've written my equation down here. And is the square root isolated on the left-hand side? Yes, it is. So step 1 is already done for us. Step 2 says to square both sides of the equation in order to remove the radical. So on the left-hand side, I'm going to have the square root of x plus 5, and I'm going to square it. And on the right-hand side, you must write parentheses around the x minus 1 because you're going to square that whole quantity. Be careful, do not just square the x and the 1 independently of each other. That would be wrong. So on the left-hand side, I'm squaring a square root. They undo each other, so I just get left with x plus 5 equals x minus 1 all squared. There's two different ways of figuring this out. The longer method goes back to basics. What does x minus 1 all squared mean? It means x minus 1 times x minus 1. Excuse the bad handwriting. And how do you multiply two binomials? By FOIL. So first, x times x is x squared. Outer, x times negative 1 is negative x. Inner, negative 1 times x is negative x. Last, negative 1 times negative 1 is positive 1. So you're going to get x squared, middle two terms add together, negative x and negative x is negative 2x and plus 1. So that is what I'm going to put over here on the right-hand side of my equation. As I said, that's the longer method. The shorter method to square a binomial is take the first term and square it. So you take x and square it and get x squared. Middle term is twice the product. 2 times x times negative 1 is negative 2x. And then finally, last term squared, negative 1 all squared is positive 1. It doesn't matter which method you use as long as you get these three terms. So now we've finished step 2. And step 3 says to simplify and solve the resulting equation. Well, what type of equation do we have here? It's degree 2. It's quadratic. That means we want to factor or use the quadratic formula, so I must get 0 on one side. So I'm going to have to subtract x from both sides of this equation. I'm also going to have to subtract 5 from both sides. And please make sure you line up like terms. So on the left-hand side, I have x minus x is 0, 5 minus 5 is 0, so I get 0 on the left-hand side equals x squared, negative 2x minus x is negative 3x, and 1 minus 5 is negative 4. So now I have my quadratic equation written in standard form, descending order with 0 on the other side. Hopefully these factors will come to you quickly, but if they don't, I'm going to show you how to figure them out. So we're going to compare it to ax squared plus bx plus c equals 0. A is the coefficient of the x squared term is 1, so this is going to be the easier factoring problems. B is the coefficient of the x is negative 3, and c is the constant term of negative 4. So you multiply a times c, 1 times negative 4 is negative 4, and I need two numbers that multiply to AC, or to negative 4, and they need to add to B, which is negative 3. As they multiply to a negative, the signs are different. And since they add to a negative, the bigger number has to be the negative one. So let's start with 1 and negative 4. Those multiply to negative 4. And what does 1 added to negative 4 give? Great, negative 3. That's the number I'm looking for. So these are my factors since a was equal to 1. So I have 0 equals x plus 1 times my second factor, x minus 4. So now I've factored it. 2 factors multiplied together equals 0. Set each of them equal to 0. So I have x plus 1 equals 0. Solving this by subtracting 1 from both sides, we get x equals negative 1. Second factor set equal to 0. X minus 4 equals 0. Add 4 to both sides, x equals 4. So now I have done step 3. But don't forget, you must check your answer for extraneous solutions. So that means you have to check them each in the very original equation. And since I'm running out of room, I'm going to put this on pause briefly. So now I'm going to check x equals negative 1 in the original equation. That means I'm going to put a negative 1 here and here. So I have the square root of negative 1 plus 5 should equal x, negative 1 minus 1. So I have the square root of negative 1 plus 5 is 4 should equal negative 2. Well, what's the square root of 4? When you have a radical sign, it means you must pick the principal square root, which is the positive one. So the square root of 4 is 2. So does 2 equal negative 2? No. So x equals negative 1 is an extraneous solution. Now let's check x equals 4. Put a 4 here and here in the original equation. The square root of 4 plus 5, does it equal x, which is 4 minus 1? Does the square root of 4 plus 5 is 9 equal 4 minus 1 is 3? Remember, the square root with the radical sign means pick the positive square root. So the square root of 9 is 3. Does 3 equals 3? That is correct. Therefore, x equals 4 is a good solution to this equation. There's only one solution to this equation, and it's x equals 4.